Hi, this is Stephen Brower from Raton Valley Community College. This is meant to be an addendum to Irvine Chapter 10. So in Canvas are the slides, the publisher slides for Irvine Chapter 10. And what this is going to be is sort of an addendum, which would be an example that is my example that I would use. First, remember in Java, I know you guys miss Java, but remember in Java, now here I have the UML for car, and remember in the UML, this piece right here, these are the fields that the class will have, and then these here, these are the methods that would be in the class, and this here is the constructor. And if we were to create an object or create an instance of car, in other words, to create a car object, we would use something like this. So the year model here would go to the initial year model. The make here would go to the initial make. Now there is a speed field, but it's not being passed into the constructor. It's going to default to 0. Well, imagine if we were just able to take this first piece right here, just the fields, and do that in assembly. That would be a struct. So what a struct does is it takes a series of, basically data. So it's a series of variables, groups them together into what's known as a struct. An instance of a struct would be called a record. And so this would define a car record called car1. Now, there is no constructor for struct. It would be positional. So 1972 goes to the year model, Trans-Am goes to the make, 0 goes to the speed. And this would create an instance of car. I got mail. This would create an instance of car. In Java, if we were to accelerate a car, the class would actually have a method called accelerate. Now there's no regulator here. And then whatever was using it or referencing it would give the object name dot and then accelerate. Well, in assembly, now this procedure here expects EDI as being the address to a specific car. And if we look at the calling down here, EDI is going to be loaded with the offset of car1. So EDI is going to be pointing to car, and then accelerate is being called. Well, EDI in and of itself is just a pointer to somewhere in memory. And if we want to reference a field, what we need to do then is say, basically we're telling the compiler, okay, this EDI that we have here, it points to a car, And once we know that this EDI is pointing to a car, we can access the fields that the structure has. The fields, in this case speed, as being the field, and this is going to add 5 to the speed field. So let me just back up again. This part right here, this was a method inside of the car class. Speed was private in, let's completely back up. Speed was private in Java, and then the way that we accessed it was through, this is the mutator. So this accelerate mutates speed, this break mutates speed, and so in Java, speed was private, and then the way we access it was through these public methods. Well, in assembly, these are public, and so we can directly access it. And that's we can directly access speed. And so what's happening here, the speed is being directly accessed, but it's because EDI is pointing to a car. We're basically, I have a reminder, we're basically saying this address that we have here is pointing to a car, and now we can go and reference the field that that car has. Braking, so this is just similar. This is saying, you subtract 5, and if it's less than 0, we make it 0. So this was in Java, and then calling it, there's my reminder, calling it the object and then break. In assembly, now the calling of it, let's just look down here. We're going to load EDI with the offset of car 1, and we call break. So in the break, we're going to subtract from, remember EDI is going to be pointing to a car. And so all of this is saying that EDI points to a car, and we're going to reference the speed. We're going to subtract from it 5. We're then going to compare what that speed is to 0. And if the value here is greater than 0, and I am doing a signed comparison, I am doing the signed comparison because if we're treating it as unsigned, it would be everything well above 0. But if it's, anyway, so if it's greater than 0, we just move on. If not, then we're going to go and 0 out the speed field. So it's a similar, again, it's similar to this. This is just, would be the assembly version of it. Now I do have loaded up in Canvas this program. So if you want to go and take a look at it, here's the struct that's being defined prior to the data segment. The data segment here, this is defining that car 1. This is, and there's another method I didn't go into the details of. This display car method expects EDI pointing to the address of a car, and then what it'll do is it'll display the year model, it'll display the make, which I'll get to in a second, it'll display the speed. The trick for doing the make, since EDI is pointing to car, and the second field is the make, I'm going to make a copy of EDI into EDX, add 4 to skip over the year, and then call right string. EDX will be pointing to the make. But anyway, so this demo is up in Canvas. You can go and take a look at it. What is not in that demo, but will be in another demo, is an example of an array of structures. And so here, this would be the variable name, the data type car, 10 dupe. We're going to have 10 duplicates. Now, for giggles and grins, I just made them all 1910 Model Ts. It was just fun for what I was trying to, well, fun to me, what I was trying to do here. If we look at this loop that's here, prior to the loop, we're initializing ECX with the length of the car list. We're loading EDI with the really the address, the offset of car list. And so then through this loop here, now this first part here is just for displaying the element number. But right here, the calling display car, well, since EDI had the address initially of the first element in the array, calling display car will display the first element. But here's the fun part. So add EDI, comma, type car. Well, what assembly will do, and actually will do on the compilation, it'll look at what the size of the structure is, count the total number of bytes, and that's how many bytes it's going to add to EDI. So if we have 4 bytes for the year, if we have 30 bytes for the make, and we have 4 bytes for the speed, that's 38 if I did my math right. So we would actually be adding 38 bytes. By us just doing here type car, it's on compilation figuring out, well, how many bytes does this instance of, or this record have, the structure, how many bytes does a single structure have? I think that's all I wanted. Was I doing something else? I'm probably screwing it. Well, I'll make another video if there's something I missed. Okay, I previewed the video and I made 2 mistakes that I do want to point out. One is a little more just embarrassing. That should say calling break. So that's just a little embarrassing thing. The other thing is I didn't scroll down far enough in display car, and I was referring to the displaying of the prompt as the speed. This is the speed. Another reminder, this is a speed down here. So this display car, this here is, or these 2 things here is displaying the year. This here is displaying the make of which EDX has the pointer to the make field. And what we did is we made the copy of EDI and then advanced it by 4. And then these 2 things here, this is displaying the speed. so I wasn't scrolling down far enough with that. And I lost my screen recorder.